All, welcome to Programmer's World. Myself Harish. If you are first time watching the videos in our channel, then I will give a short intro of it. So this channel completely deals with learning programming languages simple and efficiently. So if you are here to learn various programming languages in simple and efficient way, do subscribe to our channel and watch the videos and enjoy it. So let's get into the video. So in this video, what we are going to see is the last type of the flow control statements, that is the transfer statements. In the previous two videos, first we saw about the conditional statements in Python, and then the next video we saw about the iteration statements in Python. So there is remaining only one type in Python, and that is the transfer statements. So today we are going to take a look into the transfer statements in Python. So let's see what is transfer statements and what are all the different types of transfer statements available in Python. So the first transfer statement that is available in Python is the break statement. It is like a keyword also, the break. So the purpose of this break statement or break keyword is we can use this break statement inside loops to break a loop execution based on some condition. So based on some condition, if we want to discard or we want to come out of that loop execution and we want to stop the iteration of a loop, then we can use this break statement. I'll just show a sample program of how break statement works. So I open the notepad editor. Here I will use a for loop for I in range 10. So in this, if I is equal to 5, then what I will be doing is print going to break the loop. Just printing a simple statement. So, and then I am giving a line keyword or statement like break. So I am coming out of the if block. I have closed. Here I will be printing simply I will be printing the I. So how I have written the code is like, so I have written a for I in range of 10, so 0 to 9. So that what it will be doing is, inside there is an if condition. It will be checking if the value of I for each iteration, whether the value of I is 5. If it is 5, it will be printing a statement going to break the loop, and break statement would be executed. Once this break statement would be executing, it would come out of the loop and it would not print any other remaining elements present in the collection. Suppose here I have given I equal to 5. So till 0 to 4 it would be printing. See, because outside if I have given a print statement and this print statement is inside the for loop only. And then when the iteration I equal to 5 comes, in that case it goes into this if condition, and since inside this if condition we are having a break statement, so it would be breaking out of the loop and remaining elements, that is the 6, 7, 8, 9. So these and all will not be executed. So I'll just run and show this output. I'm opening the command prompt. So py test.py. So you can see 0, 1, 2, 3, 4 going to break the loop. After that, it is not printing any output. So this is one of a basic example for illustrating the break statement. Let me show another example with a list collection. So it's the same logic only. So I'll be assigning a list A equal to 10, 20, 40, 50, 230, 34, 30, 345. So I have given a list here. So here what I will be doing is for I in A. So for I in A, if I is greater than 100, then the number is greater then 100. I'll just printing and it will be breaking. So what happens? 10, 20, 40, 50 will be printed, but this 230 will not, since it is greater than 100, it will go inside this if condition and break would be occurring. And then the next element is 34. This would never be getting executed because we have executed break and it would come out of this for loop. So I'll just show this also. 10, 20, 40, 50. The number is greater than 100. So this is another example for a break statement. And then the next transfer statement is the continue statement. What this continue statement state is, we can use continue statement to skip the current iteration and continue the next iteration. The difference between break and continue is, here if you are specifying break, what would happen if this condition is true and then if the break is executing, the remaining elements in the collection will not be executed, that is the remaining iterations will not happen. But in the case of continue, if I give continue here, what will happen is, I'm just ignoring it. So I'm just saving the code. So if the number is greater than 100, I am giving continue just simply. So let's see what's the output we are getting here. So we can see the output like 10, 20, 40, 50, 34. So we're getting all the numbers that is less than 100. So if the condition is true, that is the number greater than 100, we are executing the continue statement. What this continue statement would do is, it will not come out of this if condition and it will not print this it will not execute the remaining set of statements in the for loop. Rather, what it would be doing is, it would go back to the for loop, the beginning of the for loop, and it would move on to the next iteration. So initially 10, 20, 40, 50 would be printing, and then when it comes to iteration 230, the 230, the value of 230 is greater than 100. So it gets true and it will go into this if condition, and inside this if condition we are having the continue statement. So it would skip this iteration and move on to the next iteration. That is 34. So 34, this condition fails, 34 greater than 100, and it will be printing the value 34. And then the next iteration 345, the condition gets true. Continue statement is there. It will try to move on to the next iteration, but there is no iteration because the elements has got over in the list collection. So this is the difference between break and continue. So I'll just show another example. If I want to print the list of odd numbers between 0 to 10, so I in range of 10. So what I would do is, if I percentage 2 is equal to 0, because if I percentage 2 is equal to 0, then it is obviously an even number. So when it is an even number, I want to skip that iteration and move on to the next iteration. So I'll just give continue here. I'll just save this code, run it. I get the output 13579. I get the odd numbers that is present inside the range of 0 to 10. So this is the differences about break and continue. And then the third statement that we are going to take a look is the pass statement. What is this pass statement is? Pass is nothing but it can be called a statement, or else it's better to call it a keyword. The pass is a keyword in Python where if we want a block to be defined empty and we don't want anything to be happening in that block, then we can use the keyword block. We can use the keyword pass there. It is just an empty or a null statement which doesn't do anything. It just it doesn't throw any syntax error. If we define a method or a block emptily, then Python virtual machine would be throwing an error. But in the case if we specify pass inside that empty block or method, it will not throw an error. It will just continue the execution. So where it can be used is in the case of inheritance or the case of parent-child class relationships. Like sometimes in the parent class we are forced, we would be having some requirements to have a declare a function with an empty body, and the child class would be responsible to provide a proper implementation. We can just declare an empty method in the parent class, and we can inherit that class in our child class, and we can override that method and do our implementation. So these kind of concept we call in Java as abstract methods. So that kind of concept we can achieve here in Python with the help of this pass statement. So I'll just show some sample. I'm opening the Python interpreter. So here, if I'll be giving a equal to 10, if a is equal to 10, I'm not specifying any block, means it would be throwing expected and intended block. So there should be something available. So if I give if a equal to 10, I'm giving just pass, it would not throw any indentation error. If a equal to 10, pass. So it will not be throwing any indentation error. So like this, what we can do is we can skip a particular block based on our requirements only. So if you want to define an empty block or empty method, generally Python would be throwing an error. So to avoid that, we can use the pass keyword. So this is applicable for methods also. So if I give define, so this is how we will be defining a method. We'll be seeing in deeper about the syntaxes and all. So if I give define m1, it will be expecting an intended block. Define m1 of pass, it will just not throw any error. It will just accept the case. So this is what about the pass statement that is available. Okay. And then the next statement is the delete statement. So what is this delete statement? It is also a keyword available in Python where what is the functionality of this delete statement is when we are using a variable and at a particular time of our code, when we don't want that variable, or we are not that variable is unnecessarily consuming the memory, then at that time we can delete that variable using this del keyword. So with the help of this del keyword, we can move the variable and that object, the corresponding, in Python everything is object, so that corresponding object would be eligible for garbage collection and it would be removed. Once we use the del keyword for that particular variable, that variable cannot be accessed after that. So after deleting a variable, if we try to access the variable, then we would be getting a name error like that. So we can delete variables which are pointing to immutable objects, but we cannot delete the elements present inside the immutable object. So I'll just explain these some scenarios. So a equal to 10, del a. So print a. So here what happens is a is assigned the value 10. After some particular code of logic, if I don't want the value of del a to be executed and I want to remove the value of a from the memory, then what I can do is I can just remove that and make that variable or object a eligible for garbage collection with the help of del keyword. So del of a would be deleting the variable a, and it would be moving on the object to the garbage collection, and garbage collection would release the memory that has been allocated to this object or variable a. So after when we are deleting and making the object eligible for garbage collection, and when we are trying to access the object after that, so here I am trying to access that object that has been eligible for garbage collection and we have made it through del keyword, and when I am trying to access that variable or object, I'll be getting an error called as name error. I'll just save the code and run it. So you can see name a is not defined. We are getting a name error. So the Python, the object is now, after using the del keyword, it will be eligible for garbage collection and it cannot be accessible. So this is about del keyword. And then the last point that I said for the del keyword is we can delete the variables which are pointing to the immutable objects, but we cannot delete the elements present inside the immutable object. So what I'm trying to convey here is, suppose if I'm having a string, like, okay, I will just show it in interpreter itself. If I am having a string s equal to Harish, if I use del of s, it would be accepting. S should be deleting it. So suppose if I am using a equal to Harish, and if I am trying to delete del a of 0, so this would throw an error, string object doesn't support item deletion. So what we can do here is, we can delete the immutable object only. The object only we can completely delete it. With the help of del keyword, we cannot delete the inner elements. That is, we cannot remove or delete the inner elements that is present in the object or a variable with the help of del keyword. So this is about the del keyword. And the last point is the difference between del and none. So the difference is very much simple. In the case of del, the variable will be removed and we cannot access that variable, and it is kind of called as unbind operation, and it will be eligible for garbage collection. But in the case of none, the variable will be eligible for garbage collection, but it will not be getting removed. Rather, it's just like an assignment operation. Like, what it would doing is, it would assign none value to that variable or an object, and that object will also be eligible for garbage collection, but it won't be removed until the garbage collection releases the memory. So this is kind of operation called as rebind operation in Python. So hence, after assigning with none value, we can access that variable. Whereas in the case of del, if you use del, we cannot access that variable afterwards. So I'll just show sample. I showed for del. Now I will be showing for none. So a equal to 10. So now what I am doing is a equal to none. So now if I try to print a, I have big none. The object is eligible for garbage collection and the value of a would be assigned to none, but it will not be removed and we can access that. So this is about the none difference between the del and none keywords in Python. So with this, we are coming to an end for the transfer statements that are available in Python. I hope you would have liked this video. Please watch our videos regularly and do subscribe to our channel. And if you have any queries or suggestions, please mention in the comment box. Thank you for watching.